Welcome to the second part of the lesson, and the suggestion of the content is to have a look to betweennesses in a large model. Is a very quick look. To generate the network, here we are generating a lot of instances, defining them with the different values of x, and appending them in a list. Then we move to network X, we generate a graph, and we, using on the fly defined nodes, choosing randomly from the list, using a random integer number from 0 to the length of the list -1, always for the usual problem, the first element is 0. We add edges if I1 is different from I2. This is only a specification because also an auto link is not creating errors, but it is just a specification. We will try to eliminate this specification. Okay? And then we draw the network. This is the result. Here, in this case, is evident that we have to substitute the ID with names because it is impossible to read this result. But it is very easy to do that. Let's try, and here we have the calculation of the betweennesses. In this case, a lot of different values because the network is very complicated. Let's try. This is just an experiment. What's the effect of this? Very few edges, because we are extracting randomly, and the probability of having I1 equal to I2 is very low, but maybe or an empty result, or an error, or a small auto-link results. Let's see. Nope, nothing. Let's try again. If I increase the number of elements, the frequency of the extraction of 2 equal, I don't know how it increases, but it will be probably increasing, but no, I don't know. Let's see. No, this is not a good idea. The good idea is to increase the number of edges, because I am making more attempts to the same set. If I increase the set, the probability of finding 2 equal extraction will be lower. If I keep the same set and make more extractions, I am increasing the probability, the frequency. Let's see. Okay. We don't see the edge, but the edge exists. So the edge is linking this with this. I wanted to check if this is true. What can I do? G, edges, and we see. This is the betweennesses of the nodes. No one is linked with no one, so it is completely zero. All standing alone in a place in the world, without phone, without mails, anything. G as before, I want to raise the screen. G.edges. Yeah, you see, this is the same. 8, wait, it works. The display is not so nice because we see the node alone, but the effect is working. Okay, stop. Other example. We move to more complicated objects. This one, playing with agents and nodes. And then finally, this has been created tonight to try to understand the error arising yesterday in SLAP. Playing with agents and nodes is simple, is complicated and simple. A few rows of code. We have a new method in the class you see, we have init to send the name that we choose in the construction of the instance to the internal variable name. So init automatically, being the constructor of the class, is taking the content of this dummy argument and copying it locally at the address of the instance. But we have also a completely novelty, the internal method string underscore underscore str underscore underscore is returning the name or what we want. If here return self number, it will be the number. str is used automatically as an example in displaying the nodes. In the display, this node will be labeled with AA1. We create a unique node here because the exercise is about using nodes and agents. And then we will try to do a few experiments suggested here. Sorry, I missed a detail, an important detail. We have two nodes. One is an agent and the other one is not an agent. They appear to be the same. How are they generated? Here. Add node A1, add node AA1. This is completely independent by this object. Is simply a name. Is the same name, but they are completely separated. If I ask the nodes, I ask to G to display the nodes, the result is now clarifying anything. The first is our object. The second is simply a node defined by name. Okay? Apparently, we see the same thing, but they are completely different. We have no edges in this case. If I ask to G to add the size to the A1 object, and then I ask to display with the option of data true the content of G, apply. The name of this node, which has this name, has an empty dictionary. The object being defined by this ID as a filled dictionary. It's also interesting to do that. What I am doing here, I am adding to the node with ID 11212, what you want, the address of the agent, copying it in a new key named object. Okay, now the first node has two attributes as graph, the size and the address of its agent. The node is reporting an agent. And now the trick is very complicated. What is G node A1 obj? Is the address of the agent. Correct? And what if I hit dot here and I wait? I am displaying the content of the object, not of the node. Name x and set x, which is a middle. As an example, I can use here set x 1000. And now the object has 100 within it. A1.x is 100. We have to pay a lot of attention in making the design of a structure using capabilities as this one. But we have to be aware that we have a lot of power. I repeat, I have discovered this trick reading in Stack Overflow, because this is not the main line of work, but it is a set of interesting ideas. I am close to conclude with my yesterday's surprise with the deletion of edges and the error horizon. I have to correct Slapper, but I hope it will be a not heavy task. But anyway, my experience is that when I have to modify a complicated structure, it is a good idea to do that with time, not in 5 minutes I have to modify and so on. I keep 2 hours. I control again, because the disaster is around the corner. This is my suggestion to you. When you have a strange error and you are asking help, maybe to an online discussion group, please create a small code generating the same error. Because if you ask to someone to help you and you send her or him 1000 row codes, the other guy will reply, please, I don't understand. If you send 10 rows of code, it will be clear. So here I have replicated the error of yesterday. Yeah, but this is not the correct file, sorry. It's this one. I was looking with surprise. The correct file is this one. I have simply names, not necessarily agents. The problem is already reproduced using simply name. 3 nodes generated via edges. I display, okay, anything is working. I close and the code continues. This is the structure now in SLAP. I want to delete edges, not nodes. And with NetworkX 1. I don't know, the last version I was using before, the 2, this was working. For A in gedges, you know gedges is a list of edges, print the node, remove the edge defined by the first and the second element of the tuple A. It starts working, it prints the first and then it crashes. We will see, let's have immediately a look to the message. It's the message of yesterday. So I simply uncomment. It is not necessary to comment this because the program is crashing, so no problem. And okay, perfect. Very good. Nope. Dictionary changed the size during iteration. Instead of trying to suicide myself, I had a look to the website of NetworkX. And they nicely wrote this very long message. Migration guide from 1x to 0. And in some place they wrote, we expect that this change will break some code. Yeah, effectively. We have tried to make them break the code in ways that raise exceptions. Many thanks. In this way, we have an help. Because if the reply is obscure, it's very difficult to find the solution. And here, method that used to return containers now return views inspired from dictionary views in Python, and method that returned iterator has been removed. So it is impossible to iterate upon a view object, a view dictionary of Mr. NetworkX. Being impossible, if you try to modify the container while you are using it, the program crashes. Many thanks. And we have to think about the trick. It is impossible to copy the dictionary view because you copy the address and you have the same problem. But you can copy each single item, putting the items in a new list. EE is extended edges. For A in G edges, EE append A. AA is an EE is an iterable structure because it is simply a list and it will work. At the end, we have eliminated all the edges. Let's see. I have to save. Okay, run. Okay, close. This is the printer, this printer. And now, if I ask g dot edges, empty. And if I plot again, we will have the node without edges. I wonder if I have to run again the draw. I guess yes, but let's try. If I ask only to plot, maybe in memory, NetworkX has still the previous construction, because draw NetworkX is not G, is the representation of G, which is quite different. Let's try. It's not costly. PLT show. Nothing. The previous structure has been deleted. This is good. It would be worse if we could have again the previous structure. As we modify G, internally, this is my guess, NetworkX is deleting the representation. So we have to ask to generate again the representation. I am an idle man. Instead of writing, I copy and plot. Very good. The nodes without edges, because the edges will be eliminated. A great question in my mind. If now the elimination of the node is working perfectly on the elimination of the edges, NetworkX had some strange behavior. Let's verify. This is, if I regenerate the structure, and I remove node A, G. No, I have to stop the program here, because it is internally deleting the edges. Okay, now G, remove node. Our nodes are names. They have not names. Okay, ABC, not A1, A2, A3. Sorry. Okay. Plot again. Good. It worked in a very consistent way. Absolutely no problem. As I have eliminated the node A, no problem, the edges of the node disappeared automatically. This is a very huge improvement, because I had a lot of problem with this detail. Okay. Now you know a lot of elements for using NetworkX, and I conclude suggesting you two important links. This one is to the documentation of always the latest version, so no index here. Automatically the website will be improved to contain the last version here, with an overview, a tutorial, very important, and a subpart, very useful, about the algorithms we have there. So with the introduction and these two links, you can create what you want. Okay? Stop. Now we have the perfect time to go back to the use online of SLAP, to introduce again you to your own work, which is supposed to be done to exercise with the content of SLAP. If we will have time, we will have a look to the use of agents as node using the dictionary POS as position to define where the nodes are placed. Oh, a very nice characteristics of Matplotlib is that if you use a two-dimensional space, you have not to pay attention to the dimension. The dimension will be automatically adapted to the position you are defining. This is very nice. It's simplifying a lot our activity. What do we do now? As yesterday, we could exercise online or exercise locally. Let's try online. If you have installed locally SLAP, many thanks, but it's not necessary, it is sufficient to use it online.
A very basic doubt.
Sorry?
If I use it locally, is there any difference with using it in the binder?
Yeah, the difference is that you save your modifications. You have the structure of the files.
In terms of capabilities or
no, there is another problem. If my program is running 2 hours, they kill it. Because my oligopolistic model spend sometimes 2 hours for a full run, because it's using a lot of agents for many times, and they don't accept that. It is a free service to diffuse notebooks among people, not to substitute our calculation power. So if it is a huge problem, you have to use it in your copy. But most of all, interesting question. If I am developing a new version of SLAP, how can I work online? I can. I modify all the files. Then I have to remember I have modified the file 1, the file 2, the file 3. I have to download them to have trace of the modification, and I have to send them to the GitHub that I am using. Fine. Instead, if I am using GitHub, I can have a local copy of GitHub, and the adaptation is simply a synchronization problem. I have a button, synchronize, done. So I have always the same content online and in my someone of you is using GitHub to program. Very good. As you move to create significant structure, sure, if you are writing an example like those, like these, is absolutely unuseful to use GitHub. But as you have a complicated structure with a lot of files, my suggestion is to spend 2 hours to 1 hour to familiarize with GitHub. The advantages. First, you have a copy online safe. It's their job to make the counts, and they do that. Second, also locally, GitHub is allowing us to go back. I made a lot of changes, and all those changes was completely unused. I run back, simply asking to eliminate modifications. And GitHub and GitHub is doing that for us. So it is simplifying a lot used when you have a huge work. Now, just to exercise, you can use the online version. It's if you forget the address to jump to binder, to my binder, go to my home page. It is very easy to find it because it is Terna to, as Torino, it, and here you have a running version of SLAP or the view of the file system. The view of the file system is important if we want to make modifications. Okay? As the modifications have been done, we jump back to the first page to run what? I run shell online containing a lot of help, or if you are completely knowing the details of SLAP, you can simply run I run shell, which is containing a unique cell. Before I was speaking about cells. This is a cell. And as I execute it, it will have a number. Why the star? Because it is waiting. It is not concluded. The cell can be waiting for two reasons. It is waiting for a reply from us, as in this case, or the execution time is very long. And so the computer is not replying because we have asked some very complicated calculations. In this case, project name, production, random number, I don't know, 222. How many cycle? 3. Verbose? No. You see that the problem of I-on, interactive on, here has been eliminated because this is the display, the graphic display. But the program is still alive, and or in the same cell or in another cell, I can continue to work. In this case, directly in the same cell. And this is obtained by this choice automatically as the program started within UPython. This magic command has been internally executed. Matplotlib inline, magic command now set, because before we had a warning, SLAP starting without any matplotlib magic command. We have options to modify that. If inline is not defined, also these displays will be in separated windows. So as we were working without UPython. I want to show you an interesting option. Now we have a few steps of execution. I conclude. The program finished and it is still there. Can I save this result? Sure. The first way is to print. Sure, if I print, I generate a PDF, but it's not nice. If I ask download as, look at the screen just a minute. File, download as, a very nice tool in a local installation, because here they have not installed a part. Maybe now they have, because when I asked, the reply was it is in program. It is planned to do that. Let's see. A very nice way of saving is saving a LaTeX structure. What is LaTeX? The wonderful free tool for scientific writing. LaTeX means Leslie Lamport Tech. LA is the surname of Professor Leslie Lamport. He's also a kind of rubber, but in this case it is a construction upon two names. And tech is the original structure. You have to read tech because the capital X is Chi, the capital Greek letter, because Professor, the name of the author of tech is, you helped me with Nelson and Winter, Professor, we will check, because it is important to remember this great helper of us. Wanted to write technical as name. In a very short way, T-E-Chi is tech. So LaTeX. I don't know now if it works, but locally, yes. Yeah, you saw. Very quickly, this file has been downloaded. This one. Have a look to the screen again. I received this file directly from the online website. And what the content? It was a zipped file. The content is a TeX file and free PNG. PNG means portable network graphic. If I compile TeX, Knut, Professor Knut defined the TeX. This is the compiler of TeX. When you write in TeX, you have to compile your effect. So you translate it. The source is very unattractive. But as I compile it, this is the result. Exactly the content of, where is it? The content of, disappeared. It's this here. The content of the notebook. But if I am writing a paper, I can copy and paste the source in the source of my paper directly. Pictures and results. Wonderful. Many thanks for your question, because it is originating a lot of reply. Also, this arises in my mind because I was discussing why to use online or locally. Previously, it was absolutely mandatory to use it locally because LaTeX was not generated by binder. Now, we discover that they have completed their structure. Nice. You already know, I guess, that in Excel you can write in Markdown, and in this case the LaTeX will contain the LaTeX translation of the LaTeX of the Markdown source. This is a Markdown sentence. I want sentence to be bold, 2 stars, and you see this is a MD sentence reported in bold. With the mathematical formula within it, I use the same formalism of LaTeX and a formula. $A raised to B, open curly brackets, raised to C dollar. You see, it works. And again, as I write here in this simplified way, I will obtain the same in the LaTeX file when I go back downloading. Okay, but this is not our main job now. What I want to do, let me close this execution, file, close and alt, we are online, and I want to decide to exercise in adding or eliminating factories in our structure. If I go to the 6th folder and within it I go to production, we can look at different possible script for the actions of the model. This is the simple one. Reset read script. Read script is the schedule XLS file. Okay. Or I can use model action add remove, and I see that I have reset read script, add a factory, remove a factory. This is an example. If I repeat twice, remove a factory, the world will be quite soon empty. But let's have it in this way. What I have to do? I don't want to lose the original model action, so I rename it. Rename, as an example, model action 0. Okay. Then I copy model action add remove. I copy it, duplicating. I obtain model action add remove copy 1, and I rename it as model action. Done. Now the program will run with the model following this script. Reset read script, so the content of schedule XLS. Then it will add a factory and it will remove a factory. In each cycle. The effect will be nice. Or to have a quick flow, I modify observer actions. Observer action. I modify the name of pause, and pause does not exist, so no waiting time. I eliminate prune. Anyway, it is the step not working due to the edges list, and I eliminate again pause. File, save. Save where? In the remote computer. Not here. Sorry, not file of Safari. This was a very nice error. I was asking to Safari to file. No, I have to ask to UPython. Safari is containing UPython. So the save was another save. Okay? I close. I go back to the main folder. Or if you never used ... in all the environment, Windows, Linux, Mac, ... means the folder from where we are coming. So ... is going to the 6th folder of SLAP, and ... is going to the main folder of SLAP. I run this. Kernel is a good idea. Clear output and restart. This is still here, you see, but we can also eliminate it. And here I run project name production. number seed 1, 2, 3. How many cycles? 12. Verbose? No. No interruption. So I have the movie until the end of 12 steps, and in each step we have both factory disappearing and new factory entering in our world. Quite easily, the machinery behind our appearance is very complicated, but it's not a problem of the user. Here an auto link is declared, if we have a lot of different links, and so on. At the end, the program is asking us to conclude, stopping the code. To run again, remember to restart the kernel, sure. Before exiting, it is a good idea to restart and clear output, and then to close and alt. Because if you uniquely close and alt, automatically our file with all the result is saved. I conclude with another suggestion for your own work. Let's see. Always in the folder 6th, but if you want to exercise to the other folder, do that. It's very interesting. Mainly on the basic and basic 2 classes example. The simple example, basic, and the simple example with the 2 different classes of agents. Let's have a look. Production, you know it. Oligopoly is my huge project about oligopoly. School does not work online due to TK problems. It is declared in the first page of the I run online shell or notebook. Basic 2 classes is 2 classes in basic. Basic special action is an addendum to allow us to interrupt the run and to modify something external to the agent. I don't know, the environment, external data. This has been a request of a group of students of mine, and I added it as a new tool. But if we go back to production, we can discover that we have a schedule add and remove, balanced and unbalanced. So in this case, we have problems in our production, as in your own work. The trick is, I save a schedule. As an example, changing the name. My name, I save it as schedule 0 for future memory. And I copy this one as an example, add, remove, duplicating it. And finally, I rename the duplicated file to schedule XLS, the mandatory name that SLAP is expecting to find, is supposed to find. Yeah. Now it runs with the new structure. In this case, we have a lot of problems because we have both eliminating and adding from the model action, because the model action has been modified before. No. Yeah, this is model action 0. Model action, where is it? Has been modified before. We have not closed the link to the remote website. And we have both eliminations also, both in the script up level of the model and in the red script of the model. I don't know the effect, it will be very complicated, and I suggest you exercise. We try. I go back until the main folder and I run using the long version of the sheet. You see here we have also the school project, but within Binder it raises an error being turtle based. Turtle Python class requires TK being turtle based. Turtle Python class requires TK inter and so on. How many complicated details. Here we are adding, eliminating in two ways. I don't know what will be the consequence. 4, 6, 8, 7, 8, 9 is a seed. No, it's not the project, it was the seed. I am very distracted now, I'm sorry. What I have to do? Kernel, restart and run all. So immediately it is asking us what project? Production. Seed 4, 6, 7, 8, 9. How many cycles? 7. Verbose? No. Cell current output toggle scrolling. Disaster. All output. Okay. I reproduced the original structure. It is working. This is important that you remember. Maybe it is only a problem in Safari. Maybe. Safari is the browser of Mac. But if you have an output with combined different outputs, because it is writing upon a previous output, simply toggle here, all output, toggle the scrolling, eliminate the scrolling. And you see very complicated events. Okay? Stop. Try to exercise. And if you have problems, please write to the hotline Pietro Terra. It is without charge, so you can use it. Okay? See you tomorrow for the last conversation, and don't forget that tomorrow we will have the pizza.